Alright, making a video, draft science video. Yeah, so anyway, somebody mentioned this in the comment section, so I thought I would do something about it. It's a Miles Mathis theory that pi equals 4. And this guy's done an experiment to illustrate the truth. Ugh. And it's just so bad. So the idea is there's two tubes. Balls will be run down the two tubes. So this one has the length of what's going to be called a pi, and then this one is allowed to be longer to the end. And if the two balls go down here, this one pops out and the other one doesn't pop out, goes all the way to the 4 instead of pi. So if pi was here, it goes to the 4 in the same amount of time. I mean, there's lots of obvious stuff, but I think I'll add some value okay, to this explanation. I mean, the most obvious thing would be is you could just recognize that this tube has a lot less friction because there will be no centrifugal forces that will be pushing the ball into the surface and creating more friction. Obviously, friction is friction. You can't say more friction makes the ball go faster. That would be retarded. Now, the appearance of speed is a different thing than the actual speed. And clearly, friction is friction. You just can't get around it. Friction is friction. It's always negative. It's not positive. You don't have positive friction. You just don't. So yes, this ball from here to here goes slower. And then if this tube continued, then the ball would regain its regular speed when it was out of the friction. But it's not going to do it while it's in the circle, while it's tethered, let's call it. So what I would add to this, though, is that the mechanism is kind of like you can think of gravity. Now, if this was a gravitational orbit, you can understand that there's a force of gravity, I would say, pushing force. And it's the pushing force that's combining with the velocity that wants to go one way, and there's a velocity being added in another direction. So it's a combination of velocities that turn. So it's not a frictional component. It's an acceleration. That's what we call it, accelerating towards Earth. You don't, even though in the same sense it's a confinement. It's a confinement with an acceleration because the force is being added to create the new vector. In this case, there is no force pushing it in, so there's no adding to the velocity of the ball. There's actually the exact opposite has to happen. The momentum of the ball is the only momentum in the equation. This is dead. This has no energy. So unlike gravity, gravity has energy. Gravity accelerates things. In this circumstance, there's no source of energy. The ball is the only source. Gravity can't provide energy. So there can be no addition to the velocity. It has to be a subtraction. So obviously, whatever motion it makes off its trajectory, so off its straight line trajectory, it can't be an additive motion. It can't be an acceleration. It has to be a deceleration. So the change is happening by taking away speed from the ball. The ball has again, just think about it. There's no, if I was to take everything out of here, you could look at that loop and you say there's no energy in the loop. The loop can't apply energy to the ball. It can only take it away. And so this has to slow it down because of the change in its vector. So even if you take friction out of the equation, you'd still have the same problem. So I don't have to use friction as an explanation. What I'm stating is the explanation lies in the fact that the momentum of the ball is going to be changed. And any change in its momentum, if it's not an active force applying the change, and instead it's matter, a container, a string, a spoke on a wheel, if I swing something around on a string, whatever the mechanism that I'm forcing a change in momentum with, if I'm using matter to do it, I'm not giving the thing extra momentum. I'm forcing it to degrade its speed, to change its speed. So by my theory, as I've explained, it's the dancing argument, almost like time dilation. If you're going to change the vector or the pointing vector of the momentum, you're going to have to do it by applying force. And the only place to get the force is from the actual momentum of the thing itself. So you have to take away a component of its vertical speed, let's call it, its straight line speed. You have to take a component of that and apply it to the new direction. So you have to reduce it to turn it. And it's not force plus force. It's force. It's force being used against the same. You have to subtract from the force to apply the y vector. So you have an x vector velocity, and to change it, you have to take away some x vector to apply it to a y coordinate to cause the new direction. So in that sense, you have to take from its momentum. But the momentum will be restored once it's free or liberated from the circumstance obliging it to continually change its velocity vector. So once it no longer has to keep changing its velocity vector, it'll go back to its normal speed. So in a sense, there is friction in this experiment that's probably doing some of the, it's causing some effect. But the real effect is just the fact that you're changing its direction. And it's the change in direction in real space. So just imagine the tube didn't exist and the ball was going to just do this for the fact that again, you can't have a hard force, but just the idea that there was some reason it was going to do this. You could just understand that for it to turn, there has to be the application of force. And there's nothing here to apply an active force. So the only place to get the active force, to get the energy, is from the momentum of the ball that's moving. So the ball has to move slower. And it's just obvious. That's exactly what happens. So in the experiment, this ball pops out. At the same time, this ball pops out at a distance longer than pi, this ball. So this representing pi, this one pops out at a distance representing 4. But obviously it doesn't demonstrate that pi is 4, because obviously it demonstrates that pi is 3.14 because this worked. It did obey pi rules in the circle, and it didn't obey pi rules outside of a circle. I mean, how to sit there and say, look, by straightening a circle in motion, it doesn't obey the same rules. That something moving at a constant velocity, at a constant vector, behaves differently than something you're bending. I mean, does anybody really have to say, duh? That obviously something not going straight, okay, is going to be under a different stress than something going straight. And again, the stress is that it has to it has to use its own momentum to change its vector of velocity, if that's a way I can say it. It has to steal some of the energy it has and apply it in the y plane, okay, to create the new directional vector. That's probably enough said. Probably don't need to harp on it, but this is just bullshit to imply there's anything else going on here. It's not magic. It's not a mystery. It doesn't prove that pi equals 4. It doesn't. And so this is just kind of crap. Yes, thank you very much. Till next. I mean, the fact that there's a relationship to how much that speed will be degraded to do a complete circle, and that's probably been formalized by NASA or somebody. They probably know this. there probably is some sort of consistent factor. As you make the circle bigger and bigger, the decline in speed would be relative to the size of the circle. So, but it'll always come out the same thing proportionally, in the sense that the amount of degrade in speed will be proportional to the difference between pi and 4. I mean 3.14 and 4. That's what it costs you, is the difference between those two numbers is how much it costs to change direction 4 times. Technically. If you just think of this as a square, you could sort of just think that it has to change its direction at least 4 times. Maybe 5. But anyway, it's a lot of little direction changes, but the point is, in the end, you're doing this perpendicular thing, and you can add that up into those, whatever the difference is between pi and 4, which would only be 7 yeah, 1 4, so that would be 6. If I add 1 4, that's 8 7 8 9. Yeah, I need one more, so it would be 8 6. Anyway, it doesn't really matter. Yeah, 0.86. So divide that by 4, and then you have an interesting number, right? So let's divide that by 4, and that will give us 2.1 2? No, 5. 2.15. So that might be the more important number. Might be. Well, I'm not going to worry about that. Anyway, I think I've made a valid enough point that there's no energy creating the conversion in momentum, so the energy must come from the thing moving. And that's where it comes from. It has to slow down because it has to use its own energy to change its direction. Unlike gravity, which is adding energy. Okay, till next time and such.